trace functionality inside of both the internal eDAT and the external product WTA. This is Pete Gardell from the eDAT WTA team, one of the system engineers there. But Mike Thacker will be giving the presentation and demo today, the training today. So I'll hand it over to Mike in a second, but just wanted to cover some of the things, typical ground rules up front. I am going to mute the bridge in a moment here. So if during the training session you do have questions, you can use your, if you're on the bridge, you can use your *7 to unmute your line and *6 to mute it back. And I'll be monitoring the bridge as well. But and if you do have questions and you are on live meeting, I believe and you have your microphone on, you can ask there, or you can send in your questions in the Q&A up top, and I'll be looking at that, and I'll try to keep track of that, and I'll interrupt Mike as we need to. But the other thing I want to let folks know is this session is being recorded, so we'll have a link sometime after the meeting later today or tomorrow that will be available for folks that weren't able to attend this live session. We'll put it somewhere, probably on a TIS link, as well as some other link as well. So just wanted to kick things off and say thanks for joining. And I think I will, at this point, turn it over to Mike to get the ball rolling here. And like I said, I think and Mike would concur, if you do have any questions along the way, feel free to interrupt and ask away, and we'll do our best to handle all and address those questions. All right. Hey, Mike, it's all yours.
Thank you, Pete. Appreciate that. And welcome, folks. My contact detail is on the first slide. If you have any questions during the session, as Pete said, just stop and ask questions. And you can also fire any emails or anything from the contact you have on the first slide. So welcome everybody to the eDAT WTA call trace analysis functions. I will be talking on that about a call trace functions aspect of eDAT and WTA. Upon training completion of this training session, you should be able to use eDAT WTA tool for call trace functionality. Basically, you can do call trace analysis, optimization, and troubleshooting for call trace scenarios using eDAT and WTA tool, depending on what tool you have access. And I will talk about eDAT and WTA tool in more detail as we go along with their differences also. So please feel free to stop by anytime, any questions you have, and I will try to answer them, or Pete will also help me here. So thank you, Pete, for that. Any other questions before we start? Any questions before we jump into the material?
The conference has been unmuted.
Do we have I just want to ask and see if we get a response. Are people hearing us okay? Anybody on the bridge can respond to that, please? Or can you guys hear us okay?
Hello, are folks able to hear us?
Yeah, I'm okay.
Okay, great.
Thank you.
Thanks for the confirmation.
Thanks. I'm on slide 3. The agenda of today's call trace training would be to go over the overview. What is the difference between eDAT and WTA tool from call trace perspective architecture, the tool, how to install eDAT and licensing of eDAT. And then we will go over call trace from call trace log data files, and I will walk over some scenarios how to do call trace if you have call trace log files from lab or field. And also we will talk about how to start call trace using eDAT or WTA. And I have some backup reference slides. I do not intend to go over their slides, but you can keep that as a reference for any further questions or any information you need on that. So let's start on the slide with that. I am going to on slide number 5 now, eDAT WTA LT call trace functionality. So what is eDAT and WTA call trace. It's a PC-based client application. Basically, you install this eDAT WTA software on a PC, and you are able to do call trace functionality if you have the log files. So it post-processes call trace data which you get, those log files from eNodeB, MME, or SNP gateway. So this tool will post-process and will do everything for you, so it makes your life much easier when you're doing call trace analysis. It gives an end-to-end view of call trace as per 3GPP specs, and I will give you the 3GPP specs number which it follows in subsequent slides. And while doing the call trace, it will decode the NAS messages, the ASN1, GTP v2, and diameter messages. It will work with interfaces with MME to eNodeB, the S1 interface, to S gateway, the S11, S6A, S3, and S10, all the interfaces from MME perspective. Any messages going on those interfaces will be decoded. From eNodeB's perspective, any messages going from eNodeB to MME or any other eNodeBs, which is S1 MME or UU going to UE or X2 interface, this will all be decoded by the eDAT and WTA call trace function. Even for SNP gateway, the S11 and S5, S8, those also will be decoded. So the interfaces are all decoded, and you are given a nice pictorial view of the call trace, which will help you to debug further. It supports per call analysis, so you can do 1 UE per call analysis. It can combine call trace by IMZs, trace reference, and time, and this is all per 3GPP specs. It takes the call trace data. Let's say if you are tracing call trace from UE to eNodeB to MME, and the call trace log files are collected at eNodeB and MME, it would correlate the call trace log files from eNodeB and MME and give you one good view, one single view, so that it's all put together for you to understand. It decodes any 3GPP protocol messages, and it also has ability to do automatic data collection. If you were to fire up the call trace tool, initiate the call trace from eDAT or WTA, it would keep on collecting the data files for log files which are gathered as the call trace progresses, and it will keep on adding it to your views, so that you have a composite one view and you don't have to go fetch the call trace files again and again. So all that is done under the hood for you, so it gives you a very nice human interface and takes care of all your needs from call trace perspective. Any questions on slide 5, please? Moving on to slide 6, please. So this call trace, which is designed for eDAT and WTA, it supports the tracing the entire of call signaling from when the call is from the call inception to completion of the call. So when it starts to when it stops on the ALU network elements, and it supports, as I said before, that the technical specs of 3GPP 3241, 421, 422, and 423, where this is how 3GPP has defined those specs for the trace concepts, how to control, configure, and how to manage the trace data. So all those specs are followed by eDAT and WTA for doing this call trace. In the LTE network, the call trace data is generated by eNodeB, MME, SNP gateway. So eDAT and WTA analyzes the data files from eNodeB, MME, and SNP gateway. For current release, which is targeted for March for the eDAT and WTA software, we will only post-process the files from SNP gateway, meaning that they have been collected through call trace mechanism initiated on SNP gateway through some other means, not through eDAT and WTA. eDAT and WTA can initiate call trace on eNodeB and MME also, but it will not initiate call trace on SNP gateway in the March release. We will put that functionality in a later release. But it will post-process the files from SNP gateway. If you have a call trace log file from SNP gateway, and if you're doing a call trace from a UE, then if you have a eNodeB log file, you have MME log file and SMP log file collected, eDAT and WTA will put that all together for you and give you one nice view for the whole call trace. Any questions up till now, please? You can trace.
Just a reminder, Mike, if you do have questions, you can send them on the live meeting, or if you're on the bridge, you have to hit *7 to unmute yourself. All right.
Yeah, thanks. The eDAT and WTA supports tracing multiple UEs at the same time. So when you are using eDAT and WTA, it can do single UE trace or it can do multiple UE trace also, just to know that. It correlates the data as I talked before and provides per call trace analysis. So from various network elements, it gathers these log files, eNodeB, MME, SMP gateway, and it will give you, after correlating all that data, a nice view for that. So the eDAT WTA call trace function, for as far as what does it do for the network element of LTE. For eNodeB, you can activate a trace node using on eDAT using eDAT and WTA on eNodeB. You can deactivate it, and the file which is stored on the SAM, the O&M entity for eNodeB, you can collect it and you can post-process it. eDAT does that all for you. For MME, you can activate the trace, you can deactivate the trace, and also post-process the MME call trace log file using eDAT and WTA. For the S gateway, you have to activate the call trace through other means. You can deactivate through other means, and once the call trace log file is stored, then you have to fetch it in the eDAT or WTA PC, and you can post-process it. Same thing for P gateway also. The collected call trace data currently by product for eNodeB is stored on SAM, as gateway, P gateway, or MME, and all of them are downloaded to WTA. Going on to slide number 7, eDAT WTA call trace capabilities. It includes activating call trace. Now, one more thing to note here is that eDAT requires licensing, and WTA also, both of them requires licensing. So you need approval for that licensing, and when you start it, it will ask you for those. And but for starting or activating call trace through eDAT or WTA, you need another license. A separate license is needed. So once you have that separate license, you can initiate call trace through eDAT or WTA. Without that license, you will not be able to initiate the call trace from eDAT or WTA, but you can post-process any call trace log file if you don't have that license. Any questions on that? Please just stop me. It decodes, as I said, according to 3GPP standards, does per call analysis, combines all the call trace files by IMSI, trace reference, or time, and it correlates the data between network elements. And I just want to make sure I repeat this so that everybody understands it. And it's important to note that it decodes 3GPP protocol message, and it analyzes and automatically collects the data from the network element as the call trace progresses or as the call progresses. This slide number 8 shows a little bit of architectural view of how the eDAT WTA function fits into the network element. You see eNodeB, which is RRCX2 S1 interfaces, and that call trace, once you start on eNodeB, it's collected at SAM. From SAM, eDAT and WTA interfaces from SAM and collects that log trace files from SAM and post-process it. eDAT and WTA will connect to MME and SMP gateway and pull out the log files collected at those network elements. Once it does that, all that log file, it post-processes the data, gives you a statistic metric view, a call message flow, and events, and you see some minute screens here, which is what we will see them as I demo them as I go along the slides. Those are the those are the screenshots for how eDAT processes that data file. In LE 3.0, I already said what interfaces they are. This is just a slide again mentioning the same interface. All these interfaces are supported from MME, eNodeB, and SNP gateway. And for the call trace type, as per the 3GPP specs, which was mentioned before, MME supports management-based call trace. eNodeB supports management-based call trace. In that, it could be a cell traffic trace, event-based trace, and it's stored and initiated on SAM aux server. Just to mention that it also can be used, you can also use XMS, but we are moving towards SAM, so that's why the slides are mentioning mostly SAM here. An SNP gateway, we only have debug traces. These are low-level debug traces, and these are the SNP S7750 service routers. So we have those debug traces. And as I said before, we cannot initiate the call trace or stop a call trace using eDAT WTA, but we can process this debug trace call trace files in eDAT and WTA if we have access to those. The eNodeB also supports signaling-based call trace initiated from MME, and I will talk about differences between management and signaling-based call trace in subsequent slides. Any questions on slide 9, please? Moving on to slide 10, please. So in LE 3.0, when you collect a call trace on MME, the call trace log file which you get from MME, it's in proprietary format, Alcatel-Lucent proprietary format. It's not in any standard format. And eDAT takes this proprietary format file and post-process it. What is the call trace log file format for eNodeB? It's following the 3GPP standard XML format. So basically tag delimiter format of XML file. And eDAT will take this and post-process it. I already talked about SNP gateway. It's a proprietary debug format, and eDAT and WTA can post-process those proprietary debug format also from 7750 service router. What is the trace depth? How far can you trace? In MME, maximum, eNodeB also maximum, and the SNP gateway is a debug trace. So basically, we can go and trace it as far as we can. And the limits, as Pete corrected me right in the, thank you, Pete, for that. In LM 3.0 for MME, release LM 3.0, we can support up to 40 simultaneous UEs per MME. So if you were to start a call trace on MME, maximum call trace would be for 40 UEs. And this is more like a product, just to mention here, like a product limitation, not the eDAT limitation. This is what product says. This is how much you can start a call trace, how many UEs you can start on MME in LM 3.0. In LA 3.02, you can support up to 100 simultaneous UEs per eNodeB. Again, a product limitation. But eDAT can process these files, 40 or 100 as the case may be, from MME or eNodeB. Any questions on slide 10, please? A raw data file sample, if people are wondering what sort of data file does when you collect a log trace file from a network element in LTE, what does it look like? So I have shown a XML eNodeB call trace sample, a tag delimiter type of sample, as you can see that, and not a very easy way to know all the stuff if you want to decode, but eDAT takes WTA, and eDAT takes this and puts it all nice in a nice graphical perspective for you to understand, and gives all the details and necessary information elements, everything, all details are given out to you when I will show you the demo there. So this is an XML eNodeB call trace sample on slide 11. On slide number 12, the slide number 12, after post-processing that file, you can see the graphical view how eDAT shows that file. The UE is on the left side, eNodeB is in the middle, the MME on the right side, and you can see all the messages going back and forth with interfaces and protocols nicely laid out for you along with timestamps. And there are other capabilities as we will walk through after you get and show this data. You can do a lot more other things after this data is represented for you. Any questions on slide 12, please? Moving on to slide 13, a similar example of an MME proprietary format call trace log file. You can see this call trace. This is a raw data file which if you were to collect and start a call trace on MME in the lab or anywhere today, you would get a protocol monitor log file containing this data like this. And again, on slide 14, I have a sample of post-processing that file. Once eDAT or WTA takes that file, it post-processes that file, and this is a message explorer view of that file, which shows the messages and other additional info and other details. We will talk about it more in subsequent slides. Any questions on slide 14, please? So, folks, if you have heard about eDAT and WTA, I'll go on to section 2 now. Just I've been mentioning eDAT and WTA. These are both RF tools from our group and our department, and I will give out some differences. What is the difference between eDAT and WTA, just to give you a good understanding of it, so that if you come across those tools, you know what it represents. The eDAT tool is for our ALU internal users, and it's mostly used internally between Alcatel-Lucent, and WTA is a productized version which we sell to the outside customer, outside ALU external customers. So these are the tools, eDAT and WTA. They do also have some functional differences. I will talk about it more in that subsequent rows. The technology supported on eDAT, LTE, WCDMA, GSM, CDMA, EVDO. So basically all the technologies which we are working with now in the product side are supported on eDAT. WTA supports, and WTA is mostly a call trace analysis function, wireless trace analysis function, that's what it says. And that mostly is for call, right now it supports call trace for LTE and WCDMA. So eDAT post-process data file, call trace files. It would, for LTE, any LTE call trace file. For WCDMA, it would post-process those files which are mentioned on the slides there. And CDMO, EVDO also, it would post-process RF call trace files. It will also do drive test UE logs. So if you are performing any drive test using UEs and gathering the data using LGLUNT or any other tool which you have, and you have LLDM files which are generated by those tools and any other tools, all those post-process will be done by eDAT. So eDAT will do layer 1, layer 2, and layer 3 messages. And all those will be post-processed by eDAT. So basically, eDAT is a bigger and more powerful tool than WTA, whereas WTA on the other side, as you see, it will only do call trace and layer 3 messages. So it will not post-process layer 1, layer 2, or drive test data. So WTA is more from the perspective of eNode B, MME, and SNP gateway from the network element perspective. Whereas eDAT will also take UE log files, LLDM log files, or drive test data collected and post-process it. eDAT can also do handover metrics, which is a different tool which our department has, and it can do other tools also. It can take other tools' data and post-process it and give you much more deeper and wider analysis. And I will talk about that in subsequent rows again. So as I said, eDAT supports UE logs. Agilent is a third-party collection platform. Agilent we have, and that's what it says. For LTE, it is now changed JDSU. So JDSU, NICT, LG, LLDM, sorry. These are supported. These are the third-party tools which are supported on eDAT. For WCDMA, there is another list of tools which eDAT can post-process those files, take those files from those third-party vendors and post-process it for your analysis. And CDMA, EVDO, and all those, these are mentioned here. WTA is does not post-process any of this external third-party collection platform files. It's as a more towards the network element, as I said, so it's focused more for call trace perspective from eNodeB, MME, and SNP gateway. Any questions on slide 16, please? Moving on to slide 17, continuation of that table. eDAT supports for LTE, MME, SAM, XMS, eNodeB, SNP gateway, and for WCDMA RNC, EVDO, it will do cell site RF. For WTA, it supports MME, SAM, XMS, eNodeB, S gateway, and P gateway, and for WCDMA, it supports RNC. So, internal tool interfaces, eDAT can post-process files from PDM, packet data monitoring tool, which we have, another tool. It will do voice quality. ROA is another tool we have for voice quality. eDAT can even post-process those files and add that into the perspective for user. A network traffic tool called WINS also will be post-processed, or SynchroTest, which is another automation tool. All this can be post-processed by eDAT. WTA does not support any of these tool interfaces. Once you post-process the file in eDAT or WTA, you get various representation of that data. The way you can represent the data could be a map. If you have a graphical map, you could see where the cell sites are, and you could see the other things, events occurring on the cell sites at various graphical locations. You can do a map plot, scatter plot, histogram, grid, and comma-separated values. All those data displays can be done using eDAT. For WTA, you can do scatter, histogram, grid, and CSV. As you see, you cannot do map because we are not supporting drive test data, as I said, in WTA, so we do not have map there. Any questions up to slide 17, please? Functionality-wise, on slide 18, between two eDAT and WTA, both of them can do metrics, statistics, and report. After you get all the call trace log files, you can do metrics, statistics, and report. For file management, WT can do secure shell, SFTP. You can do SSH or SFTP to the network elements, MME, and eNodeB or XMS in that case, or SAM. And you can do that and using SSH or SFTP, and I will show that in subsequent demo how to do that. You can get those files from that network element. User-defined reports can be made in WTA, and command line report CLI can also be supported. So you can see the differences between functionalities of eDAT and WTA. eDAT has a lot more functions, and whereas WTA has more towards specific towards call trace. Message Explorer, message flow, per call analysis, and event timeline are both in eDAT and WTA, versus in eDAT you can do neighbor list analysis for cells, you can do drop call analysis, coverage analysis, and other things which are much more powerful in eDAT. Any questions on slide 18, please? No questions? Then I will move on to slide number 20. We are in the architecture section. As I mentioned, there are two call trace activation methods, management base or signaling base before, and this is the slide which will give you more perspective from the 3GPP standards. What is the difference between those two? A management base trace can be initiated from an EMS element management system to the network element. In our case, this could be MME or other as a start. So in our case, it could be eNodeB here. As you see, the element management system is either SAM or XMS, and you can see the eNodeB getting the management trace activation from either of this entity. In the pre-LA 3.0, we support XMS, so product supports that XMS, and pre-LA 3.0, so we have that XMS eNodeB interface. In LA 3.0 and beyond, we will be using SAM. So SAM interfaces with eNodeB as element management system to activate the call trace. This is the management base call trace. So what is the signaling base? The signaling information mostly is in the MME for our network. So if you have an element management, which we can start the call trace, EMS is basically to use for O&M purpose to start the call trace. The any here being MME, you gets the request to start the call trace, and then it says I will have to propagate this trace parameter to another subsequent NEs, which is in this case could be S gateway, P gateway, or E node B. So basically a trace parameter is configured on one main NE, and then it propagates to other subsequent NEs as is shown in the graph, in the chart there. So in this case, the MME is the main network element, and it propagates the trace parameters to either S gateway, P gateway, or E node B, or from E node B to another E node B using the X2 interface. So from MME, S1 messages are sent to start to E node B, and X2 messages are sent from E node B to E node B to start the call trace. And S11 and other interfaces are used for S gateway and P gateway. So basically, this is the signaling-based call trace. Any questions on slide 20, please? If you were to activate a call trace on using call trace and trigger, and you were to start a signaling-based call trace, the E node B call trace will be triggered through MME. So MME will send a trigger to E node B if it's setting up a signaling-based call trace, and that's called signaling-based call trace there. If you were to do a management-based call trace, you can do directly on MME, and you can do it on E node B either using SAM or XMS. So there could be a signaling-based trace could be on E node B through MME. A management-based trace could be on MME or E node B. And you could also do an event-based trace. If a certain event occurs or triggers, like so many dropped RRC or something, connection request failures, RRC radio resource connection failures. If you say, if I have some, let's say 100 connection RRC radio resources failures, I want to start a call trace to see what exactly is going on. You can do that through using eDAT or WTA, and that can be set on E node B via SAM or XMS. So I will show those screenshots too. So there are three types of call trace: signaling-based, management-based, or event-based call trace. And I'll be showing you subsequent screenshots which will allow you to set any of these call trace and start that call traces. Any questions on slide 21, please? As I said before, we don't use SAM. We use SAM from LA 3.0, and before LA 3.0 we have XMS. So I have mentioned both of them here. Again, some more detail on management-based trace. Management-based trace, as the slide I showed before, can be activated or deactivated from an element management system, EMS. The eDAT or WTA will connect to that EMS and request call trace activation, deactivation through that EMS. The trace in a management-based trace is not propagated to other NEs. Again, I showed that in the slides before, 2 slides before. I showed there is no propagation to other NEs so there is not propagated from one network element to another network element. If you were to start a management trace on an E node B, it will not be propagated to another E node B. E node B management-based types. What are those types of management? You can do cell traffic trace on an E node B. When a call, E node B starts a trace recording session whenever a call is started on the monitor E node B cell, or you can do event-based call trace on E node B. Again, I will show those slides in more detail when we go to the screenshots. Any questions on slide 22, please? More details on signaling-based, slide 23. Signaling-based trace is activated, deactivated from MME. In our case, eDAT WTA will provide the connectivity to MME. So eDAT or WTA PC, where you are running that eDAT tool, will provide that connectivity to MME, and it will request call trace activation, deactivation to that MME. A trace reference is maintained across any. So when you were to start a signaling-based trace, according to the 3GPP specs, a trace reference is maintained across the network elements. If the call trace goes from MME to eNode B or SNP gateway, a trace reference is what helps you to tie all that information together. And the tool does that all for you. So you will see that in subsequent call flow analysis, you don't have to do any of that stuff. The eDAT and WTA tool takes care of your full call flow. eNode B, which will receive the signaling trace propagation command from MME or from other eNode B. S1 message is the one we use for communication between eNode B and MME. So that will be used to propagate that trace command from MME to eNode B. And the X2 message will be used. That's what we use between eNode B. So from eNode B to eNode B. So that same X2 message will be X2 messages will be used to propagate that command. And S11 will be used for S gateway to P gateway from MME for signaling based trace. I did talk about this before, but this is just some more details there. And the event based trace, which is the third call trace, signaling based management and event based. Currently, you can support traffic thresholds. You can set this traffic thresholds, the number of connected UE ratio for the monitor eNode B cell. If that exceeds certain limit, then you can start doing call trace on that, because you think that, okay, this many UEs have connected, I want to start call trace after that, or thresholds are this much is my threshold for that, and I can do call trace after that, something of that sort. So that thresholds are configured through eDAT and WTA screens. So they will allow you to set those thresholds, and I will show you those screens there in subsequent slides. Another threshold is RRC connection reestablishment method. How many RR radio resource control messages reestablish attempt occurred? I want to know that. If there are exceeding certain amounts, I want to see what the problem is. And you can set that threshold on that screens. Again, I will show you that screen, so this will help you in debugging your network. If you have iWrite handover, too many iWrite handovers are occurring, and you want to set a threshold. If I see so many iWrite handovers, why are these iWrite handovers going to other technologies from LTE? You can set those thresholds, and you can start your call trace to debug that using those screens. And I will again show you those screens. Any questions on slide 24, please? Again, some 3GPP spec standards here regarding the trace reference and the trace recording session reference. As you see, this is defining the 3GPP spec. What is a trace session reference? It correlates to IMSI at MME and SNP gateway. So if you are looking at MME or SNP gateway call trace, it would correlate to, in some way, the trace session reference would be correlated to the IMSI. If you were to do a signaling activation at eNode B, the trace session reference correlates to IMSI for that case. But if you were to do a management activation at eNode B, it will be correlated to the eNode B ID. So this is how a trace session reference is used in eDAT and WTA, and this is defined in the 3GPP specs as shown. You have a trace recording session reference. These are two different things. What does that do? These are correlates to a trigger at MME or SNP gateway. So the trace recording is related to the trigger at MMP and SNP gateway. That's what it means. It has no real meaning for signaling activation at eNode B. If you were to do a signaling call trace, it has no meaning for trace. If you look at the trace recording session, it does not give you any information for eNode B. But it will correlate to UE for management activation at eNode B. And this is as per the 3GPP specs mentioned before. Just a reference to you. I have on section 4, eDAT installation and licensing detail for folks who have not installed eDAT yet or have not used it. This has some more details on it. Where to get the software, eDAT or WTA. WTA is not on this side, by the way. eDAT is on this side. WTA is an end customer. It will be on OLCS and site. So it's an external site with users, external customer can access. But if you want to do eDAT installation, you can install it and you can go through this website. It has some hardware and software requirement. What would eDAT need from the PC's perspective? What sort of processor, RAM capacity, operating system, what is the capacity of hard drive, resolution of your display, and the software, any other vendor software which you might need. One thing I just want to point out, this .NET 4 is what you would need. Many times people do have older versions of .NET, older than meaning .NET 3 or .NET 2. You would have to get .NET 4 from Microsoft website, and again that links are provided. If I were to move on to slide number 28, you will be downloading eDAT from Navigator Web Alcatel-Lucent, which is a 5.5 version if I'm not wrong currently there. We are developing 6.0 version in the final phases, which will be released end of this March. So it's pretty soon due out to be released. Most of my demos today will be based on that newer version 6.0. Once that thing is released, eDAT 6.0, this website will be updated with 6.0 version, which will be end of March or beginning of April soon. Any questions on how to install? This is a website where you can go and install your eDAT software if you have not installed it. Continuation of that installation, it provides 32-bit version or 64-bit version. Most people install 32-bit version. That's what our XP and other operating systems are. If somebody has a 64-bit operating system, we do have a 64-bit eDAT as well as WTA software. Any questions on eDAT installation? Moving on to eDAT licensing. Once you install the eDAT, you need a software license for eDAT where you have to enter your CSL and login password and an OI code. Now this is the OI code. Depending on your organization, you have OI codes assigned, but if you don't have that, you can email this navigator@alcatel-lucent.com for any problems, and somebody will get back to you for supporting that OI code and how to install and giving you this information so you can install it. Remember I said that before, once you install eDAT, you may not have, depending on that OI code, a call trace activation license. For activation, meaning that if you want to go ahead and activate a call trace on a network element, you need a separate OI code for activation. So if you think that you need to activate or deactivate call trace on a network element, then you would need to get this second OI code, request that again to give the ability for you to start and stop call traces. If you don't have that OI code, you will not be able to start or stop call traces, but you can still post-process the call trace log file from MME, eNodeB, SNP gateway, and you can still view the call trace data and everything else. It's just that you will not have the ability to start and stop the call trace on the network elements. So if you think you would need a capability to start call traces or stop, then please make sure you request the right OI code also through that Navigator help alcatel-lucent.com. Any questions on slide 30, please? I'm in slide section 5 now. Call trace from call trace log data file. This is where I will start doing some demo also along parallel with talking you over the slides. So please bear with me. I will be juggling two different things here, demoing from what data files I have, how to do call trace. So any questions, any thoughts up till now? I am on slide 31. We are almost in the middle of the presentation as of now. So any thoughts, any questions, please?
Just remember, if you're on the bridge, you have to hit *7 to unmute yourself if you want to talk.
Okay, on slide 32, feel free to ask questions anytime when I'm doing this demo and talking all at the same time. I'm on slide in the section where it says call trace from call trace log data file. So now this section assumes that somebody has given you a call trace log file collected from any like MME or eNodeB, and you already have that data call trace log data file from a let's say a customer site which has some issues, or you have got that yourself by starting a call trace and you have that data file already. So you don't, I'm going through that section of demo right now. So as I have on slide 32 some screenshots, pretty small, but I will try to walk over those, and that will be more meaningful for you. Once I walk over, those will be much better represented. So bear with me. So now here I am on a eDAT. If you can see my eDAT, which has a 6.0021 version. As I was saying, I have a later version of eDAT. I can go to File, where I have to start and get a call trace log file from a network element, or I may already have that on my PC. So let me start with the most simplest case here, which means that I already have a call trace log file on my PC. I have it all. I have got it somehow. I have copied it from somewhere, and I want to post-process it. So if I was to go to this file menu, I will say I want to create a new project. That means I don't have an existing project. A project is a definition, but in eDAT term, its own project. So I have to create a new project, and it will give me a open, select the file to add to the project window. I hope folks can see that. If you don't, then please let me know. I have some call trace log file already collected on my PC, so I'm going to, and those are on my desktop, so I'm going to click desktop, and I'm going to move to the folder where I have my presentation slides, which I had kept some of the demo data files there. In my presentation, I had a folder there, which I had kept some demonstration data file. So in that, I had collected and attached tracking area update X2 handover file, which I have collected. So I'm going to add that file and open, click on that open as you see them. If I'm going too fast, just let me know. I have to slow down, and I don't mind slowing down. So basically, I'm taking this call trace log file, which has been collected from field and given to me to post-process in eDAT. So it's a zip file. So let's see open. Even eDAT can open a zip file also if somebody zips it up for you. And if you were to put the cursor there, you can see that it contains the eNodeB XML files, and it shows all the MME files. There is an MME file also, I believe. So let's see open and see what it has in there. When eDAT opens that zip file somebody send you, or you have it, it shows that it has eNodeB XML files in there. I told you eNodeB call trace is an XML file, so it has those XML files in there, and it has decoded the zip file, and mostly all of them are in XML file, but there is a protocol monitor log file. Now this is the MME file. As I told you before, an MME call trace log file will have protocol monitor and some date number behind it. If depends on the date. In this case, there is no date here, but it's a MME call trace log file. So eDAT unzipped it for you, and I'm just going to, and it has selected. If you want to select any particular file of it, you can click on these arrows and these check marks, and you can select only those files. In this case, I'm going to select all of them and leave them selected, and I'm just going to hit OK. So as you see, eDAT has started post-processing those files into its own data, and it's creating events, reports, statistics, and all that stuff in that. And now you have a screenshot here. Once you have loaded that file which somebody gave you, or you got it from somewhere, a call trace eNodeB and MME log file, you have this case. I hope folks are following me, and I'm not going very fast. once you have that file and you had, well, the way we did it was to create a new project. I clicked on new project. Just to repeat, I selected the zip file and loaded it in eDAT. Any questions up till now? Once you have that file loaded, you want to see what are the call trace messages and the details of those messages, and you want to look into those files. You would go to the View menu here, and you see there are various options highlighted. Metric Explorer, which gives you details about metrics when it collects all these files. If you had a UE file, Project Explorer, Statistic, Delta Metrics, Info window. For call trace, these two windows are very important, Message Flow and Message Explorer from the perspective of call trace. Please note that. And we will be talking most of the time for call trace, these two things, the View, Message Explorer, and Message Flow. And these are the important things of call trace. These other things are more towards the eDAT core functions, which eDAT does do beyond call trace also, and sometimes we have some impact of call trace on there also. If I was to look here in the other menus, just to go over, this is the menu I was talking about, call trace, initiating the call trace. I will be talking about it in a subsequent demo, but this is where you need the OI code. If you don't need the right, if you don't have the right OI code, this menu will not pop up. If you have just eDAT license and you don't have the call trace initiation license, then this you will not see in your eDAT installation, this initiate call trace capability. So I keep on rubbing it again, sorry about that, but if you have the right OI code, you would see this. I do have it, so I do see initiate call trace, and I will demo that later. The Tools tab provides various things, again eDAT related, and there is options for setting any settings you want to change specific to your user needs, and the window and a help. So let's go to the call trace part of it. The message flow part I will start, and message flow comes up with the pull down project 1 study 1. Now that you have loaded this file which I showed you, I just showed you the before. We have this pull down, so I'm going to click on it, and when you click on it, the message flow window comes up, and you see the flow diagram for project 1, study 1 comes in there. This is the project you had created, eDAT has created for you by loading that call trace log file. As I'm trying to make that window bigger so you can see the details of the message flow there. And I have jumped in a little bit ahead in the section of presentation here, trying to balance this too. So please bear with me as I go back to the PowerPoint slide there. I have not done this part, but we are on this slide where I'm showing you loading the file, and now I'm at this stage where I have showed the message flow and this step. So you see the messages from UE, the different UEs here are mentioned, the names here, and you can scroll back and left and right. The UE messages going from the UE, these are all the UE, different UE numbers, user equipment, and eNode B coming here. And you see there's a lot of data. The first message coming to eNode B, IHRAN ST15. And what is that message coming? You can see that's an RRC connection request coming from eNode B using RRC UU interface from this eNode B, this UE. Now you see some of the things are chopped off. In 6.0 version, you can take this and drag it and make it bigger, and 5.5 you may not be able to do it, but you will be able to take this edge and make it bigger to see the whole UEID, and that is one of the functions in 6.0 we have made. So many scrollings you have here, you can scroll away, and that is in 5.5. So in order to avoid that inconvenience, we have some other capabilities like dragging this edge and putting it together and bringing the networks elements together. So if you do that, you can get it more, it doesn't scroll that much for you. Basically, you can see that message of attach RRC connection request coming into that eNodeB herein. If you were to click on this arrow, the message, you would see the detail of this message right in there. So the whole message, where you click it here on the top, this line, I'm sorry if you cannot see it on there, but if you do this RRC connection, you can see that it's RRC connection request here. It going from UE to eNodeB, protocol LTE RRC, interface UU, and this is the file which I loaded on it with my PC for the project. And there is some more details of the trace session reference, trace session reference ID and all that stuff, and more details, query details of bits and bytes of message, and all the information elements of that RRC connection request, which will help you to debug your call trace and allow you to get more perspective on each message. So this is the detail how message flow shows the sequence of things and messages. So this is a request and RRC connection request, connection setup complete. Again, you can see that message going back from that same eNodeB connection setup complete, and it going back, attach request coming in, eDAT PDN once the resource radio recess is established, and attach request going in from UE to MME, PDN connectivity request, again going from UE to MME, and we have, and in this case, if you see this bar, it will give you RRC connection setup event complete. So basically, radio resources have been completely set up, and now attach request. Sorry, is there a question on the bridge? Very good. Okay, one of the things while I was dragging, if you were to press the control button, and if you were to use this edge, and if you drag with the control button press, you will drag everyone together. So it brings all the network elements and the distance between them together. This is only on the first edge. So if I was to want to make them all smaller because I am having too many scrolling to do, I can do this way and bring them the whole picture together, so it gives you a better perspective of the sequence of things happening in the network. So you see the attach request event here, and I just did, and again this feature which I just did, the dragging, is in 6.0, and we are enhancing our eDAT and WTA as we go along. So this is in 6.0 version. So this was showing you the attach request event here with this pink color, and you can see that ciphered NAS content and other messages are also shown. If you have eNodeB and protocol monitor log file both, your ciphered messages will be deciphered. If you have only eNodeB call trace log files, you will not be able to decipher the ciphered messages, but if you have MME, you can get both of them. After this sequence of event of an RRC, radio resources, and attach event, you can see that there is a successful attach event complete here. So eDAT takes this sequence of event, what has happened here, post-processes in it, and it knows that you have done a successful attach event for the UE to the eNodeB and MME in the network. So there is a successful attach event here when it completes all this sequence, security mode, checking authentication, and all that stuff. So you see a successful attach event here. Then if I was to click on this initial setup, contact setup response message, you will see that the details of this message on the bottom screen here. So it goes from eNodeB to MME, the directions, protocol, interface, message name, additional info which is pertinent to this message. We put all the important stuff which we think the user might be interested to know. Some of them we will put that in additional info, and you will put the decoded message also here at there in the bottom for you to look if you wanted to look. So basically it takes out all your trouble of doing the work for decoding any call trace messages. This tool is a powerful tool to help you debug your call trace messages if you have problems in field or any network, in the network of LTE. Any questions up till now, please? I'm scrolling down quickly. After the successful attach event, I have other messages which are from the network and back and forth. The UE probably has done some tracking area mood or something, and it has caused a tracking area update request. As you see, TAO update request came along, and in order to see that, I'm going to unscroll this little bit so people can see. So I can go back and show you more on that. One thing I forgot to mention here is that whatever I'm doing all this here, this control and dragging and all that stuff, eDAT has an online help here. So if you have any questions on eDAT or WTA, you can go to this help index, and if you click on it, you will see an online help documentation here. And it describes whatever I did here. If you have anything, you can type in here how to do this, and mostly it will search in and give you things. It also has in the bottom FAQ, use cases and FAQ if you have some questions.
Can I stop you for a second? I think we've got a number of new folks that have joined the live meeting and the bridge. Just a reminder, if you have questions and are on the bridge, to unmute, you hit *7, and you can also, the live meeting also has voice on if you have your microphone on, or you can send in your questions via the Q&A. So I think I heard possibly some questions. So if you do have a question, hit *7 on the bridge, and Mike will address. Thanks.
Thank you, Pete. Appreciate that. Sorry, when I look at all these two screens, I forget to look at other screens. So I appreciate that. Thanks for pointing it out. So folks, do you have any questions up till now? Please feel free to ask. Anytime, just hit the button and stop me anytime. That's the protocol. Nothing else there. Okay. So this has also use cases in online help as we have. So if you look at use cases, it will give you some FAQ, how do I do this or how do I do that. It even has that, this online help. It also has other things in there, like as I was talking you, how to start, let's say, menu call trace. As you see, if you were to click on that, how to initiate call trace from MME, how to initiate it from XMS, how to do. And if you were to click on this and double click on it, you would see all the screenshots, and it will walk you over how to start a call trace from MME, XMS, or SAM. And so this is all in online help also. So to help you, we do have an online help, which you can go from help index here, which I just did. I am going to close this window again for any folks who missed it late. This is a help online index here to do any questions you have for eDAT tool, how to use on it. You can search it and you can read about it. But hey, thank you so much, Pete, for interrupting me there.
Mike, while you're on the screen, you showed the resizing of the columns and whatnot. Can you just show them how they can use the filter real quick to isolate an eNodeB messages for an eNodeB? So go to Filter, Network Element.
Okay, filter by message, group, or network element.
Right.
So once you have this message flow view, and let's say I said I wanted you say, oh, I have too many clutter here. There are too many UEs, too many network elements. I'm just interested in my customer who has a more something like a trace session reference, this one, or by network element, or something like that. So you can come to here, which is a filter, a funnel icon here. You see that, a funneling filter, and you can just click on this filter pull-down menu here, and you can filter by message group. So you can select a message and filter it. It can filter by mobile. So let's say if you have a mobile, you are interested, the trace session reference is this one. You would check it, and you would click on OK, and you would see only that trace session reference. You saw the screen got updated, and now you don't have that much clutter on there, only this much messages from that trace session reference UE. So you see only those messages. So this filter capability is powerful for you to get you down into the details if you want only that mobile, for example, this trace session reference. You could go back by selecting all and unclicking, or just selecting all, and you could go back to the previous screen, which is you got when you loaded that file called trace log file for all the trace session reference. So this is how it is. So you can go back and forth using different filters here. You could filter by network element. Let's say you are debugging and you said, I know my eNode B which has a problem, and the messages which are going from that eNode B are having, I want to debug it. I want only eNode B ID 2, for example, with this interface LT eNode B. I would just click on that one, and you would click on, and you would see only those eNode B messages. And since these are so small, I will press my control button and you can go back to resizing this default by pressing control, double clicking this, and you will see that when you double click it, it puts back into the default size. So you have all the distance between these two is still not correct, so I'll just double click that, and here we go again. And so we have this eNode B ID 2 messages going back and forth there. So this is what we have filtered. Currently the filter is active as it says here, and by network element ID, and I can go back again to looking at all the messages by clicking all and clicking OK, and I would get all the messages also. This is the various types of filter by message group if you want to filter. If you want to do by call ID, then you could click by call ID and you would click and you would get only those messages. If you want to do by filter group, like I'm only interested in certain messages like downlink NAS, then you would click that and you can go again and edit to what messages are we talking from there. When you click edit, you will pop up a different application, which is a tool option, which you could go from the tool option. It will pop up where you can message and go ahead and select the message group which you want to select from. That's in the application project or technologies. Okay, any questions up till now, please? Okay, guys, so this is the slide. I pretty much talk a lot about on these slides. Some of the slides also I covered, but I will go over the slides sequentially anyway. So this is how you can post-process the file. This was a message flow view. Now, I didn't talk about the Message Explorer, but let's talk about the same thing, Message Explorer. For the same study, so the same project, the same data file which we loaded, we wanted to see the Message Explorer. So if you were to click Message Explorer, you would get the details of the messages, and you could get more details from a different perspective in a different form. Instead of those message flow diagrams, you would get the source any, destination any in a tabular form, and you would get more details and columns view, message name, you would get additional information column. And again, if you were to click on each of these rows, like if you want to see this RRC connection request event or RRC connection setup, you would see this details in the bottom there. There is also a functionality if you now have a message flow and message flow, and if you were, there is a timeline functionality here also in message flow. If I was to click a timeline button there, you would see the sequence of times, I don't see that. Hold on. Please bear with me while I set it up. Okay, sorry. Here we are. On the timeline button on the Message Explorer, if you click the timeline, you will see different events occurring in the call flow. So we are plotting different events, and I'm going to bear with me while I pin this. You can pin this because it scrolls back by using this pin up button just like any software, and you can drag it. And now you can see the timeline time events occurring at any point in the stage of the call. So if I was to hover over this symbol, it says there is an RRC connection complete event here. So that is how it is symbol. It's like a TV show where you can see what happened at what time, and you can hover over the events. You can scroll them. Successful attach event occurred here, and you can click on it, and you will be going and scrolling there right into the bottom where the successful attach event occurred here. You see that. So I clicked on the successful attach event here, and it went into that. There are flags here put for those events, and you can put the flag. If you say if you wanted to debug something, and I wanted to show somebody this message for something, you can go ahead and put your own flags by going up here and adding a flag here. Like I wanted to add a red flag here because this is a problem area where I want to debug, and I want to know that. You can just click on it and put a red flag here, and you can see that a red flag is added there for you to send somebody a file with this output, and then you can send this file as an output with this red flag pointer there saying this is the area where I want you to look and see what's happening here. So you can share these files. You can save these files as a different ways and send them to look at. Any questions up till now, please? Did I cover what you expected in there, or is it pretty much?
Yeah, in the message flow, if you could just, just in the filter, show like grab an eNode B. Just to show that what happens is all of a sudden now you're just looking at the messages that go.
This is the eNode B I grabbed before.
No,
I
not
did
that
not
one.
have.
Just grab the second one. Not that
Second one? Okay.
Yeah.
So I'm gonna. Okay. Okay.
So that you limited the messages between. You've got another filter on. So.
I'm going to clear all filters.
Yeah,
That's another way. Just another ability. You can clear all filters here, and then you can start doing your filters again by network element ID, and I'm going to clear set this, and that is where all the eNode B2 messages are. So you can see the handoff request, prep failure, and only those messages.
Yeah, just to elaborate a little bit, these are the kinds of questions that we get from users a lot is, okay, I load all these thousands of files, call trace files, and that view was quite extensive that Mike showed, and how do I drill down to, this eNode B2 or, the 15? And that's what he showed you was showing filtering down into the particular interface between the two eNode B, so it's an X2 scenario, handover scenario. So that's one way to get there. The other way is by the mobile, the trace references. Those are important ways. If you load multiple UE's worth of data in here, you need to go to that, as he was shown before. The trace session reference IDs are very important to understand. And that's some of the front work that Mike went over. There was a slide on trace reference, trace recording reference, and those are important when you're talking about filtering, decall traces in particular.
Yeah, I'm showing those two trace session reference, which I'm trying to filter because the user is interested in only those two trace session reference, for example. I don't want to see those many true sets, and I would just select them. I extended the window by just dragging, and I'm going to select these two trace session reference and only show those two messages. So I'm now looking at only those two messages, those two trace session reference messages. So this is how you can use it for your own use. Once you have set the filter, there is a way to clear all filters. You can do clear column filters. These are the columns, and some of the filters are applicable on column basis, some of them on row basis. So you can click non-column filters or column filters, or you can click clear all filters here, and you will go back to your original view of the message flow there by clearing all the filters. Now I have message flow. Pete, you wanted to add anything, or I can show the sync button, I think.
No, that's it. Thanks, Mike.
Thank you, Pete. I have pinned this, so timeline, so I'm unpinning it. I want to get it out of the way. And once you have message flow and message explorer side by side, there might be times where you might want to synchronize those two. So let's say if I was to view them in a side-by-side fashion for debugging, I would say new vertical tag group. And as you see now, I have message flow on one side and message explorer on the other side. And this is the button which is synchronize. So you could click on that one, so it's depressed right now. And if you were to scan something here, you can see them, both of them scrolling together. So basically this messages explorer are the same in the message flow on the left side. So you can look at it in a synchronized way by scanning and see where this area is in my message flow when you press this synchronize button. And this is depressed right now. You may not be able to see very well in that, but right now it's a little bit pushed in. So right now the synchronize capability is active. We talked about synchronize, we talked about filter, and this is the bit that I was talking about, export the data, where if you want to export the data to somebody for some analysis or some sharing, and you can put your flags here. You can sort, ascending, descending, other ways, original, put it back, and you can put the flags as I added those flags in there to share somebody some area of what your interest in call trace. You can use a find text button also here by using this binocular button where you can type what you want, RRC connection release message, for example, and it will search for that message, and you don't have to keep on looking all over. So you can do that, and it will find RRC connection. As you see, that RRC connection is what I typed, and it has searched that in the message explorer view there. So there are ways to dissect this data and use this data for your own analysis. Any questions on this, please? This is the call trace message flow view and message explorer view. And we used an existing data file which was existing on my PC. I had already got it from the lab. So this is how you would use it. Any questions before I jump into some more other capabilities of call trace? Not, I can just close this window here by clicking on the X, so the Explorer window is closed. I have the message flow now taking over the screen, and I can close that one also as such. I can close the project file, close project 1, which is what the project 1 was when we loaded that whole data from the lab. Do you want to save changes? I would say no, because I don't want to save any changes. Now I'm going to demonstrate another capability which is on slide number 33, which was, we have completed slide 22, where call trace data was already on the eDAT PC. Now what happens if the call trace data is not on your PC? I'm going to demonstrate. That means first of all, you would have to pull that file from MME eNodeB, or which is SAM in this case, or XMS, into your PC before you can do this, what we did before. So what would you do is to, as I have this slide, you would go there, file, manage files, networking, as it shows a step. I would be going from here, from file, and I want to manage my files. So I'll click manage files, and it will come up.
Slow down when you move between the views.
Okay, thank you. So this is the slide which I'm talking about, slide 33. Thanks for pointing that out, Pete. As you see that This slide shows you the demo of bringing the file from MME or SAM into your PC. Before, the demo was already as if the file was on your PC. But now what happens if the file is sitting, call trace log file is sitting on MME or SAM or XMS? How would I bring that back into my PC? How would you bring that into the PC? Of course, you could do some other ways, but the tool allows you that capability built inside that self. And what would you do is to go to File, and then you would click this Manage File button. Again, I have that slide explaining that, and you can see that when you click that File, Manage File button, a window pops up with two tabs on it. One called localhost, meaning yourself, your PC only, and if there were files sitting in your PC, you would see them in that directory here. But in our case, the files are now sitting on MME or SAM or XMS, and I want to bring them into my PC, the call trace log file, before I can post-process them in eDAT or WTA. And this is that symbol. If you see, hover over it, you will see that it allows you to connect to a remote network element and download the files. This networking symbol. So you would click on that one, and you would see a window pop up to connect you to a remote network element. And basically, this is the networking symbol which says, I'm going to give you ability from eDAT or WTA to connect to a remote network element and download a file from that network element. I had a IP address which I might use here and show you the function, how to download the file from that function. Please bear with me while I bring up that IP address. Okay, here we are. Okay, so I am going to do a lab I know here, which is somewhere I'm going to connect. I know the IP, so I'm going to connect it and to that lab and see if I can download that file from that lab. I entered the IP address of that lab, and I know I want to connect it to MME to get that log file. This is the IP address of that MME. I can have other element. I can connect to SAM. I can connect to XMS here. WMS is for not now. It's for WCDMA, so don't worry about it. But XMS, SAM, and MME will be what you would usually connect as LTE support. And you can pick up the network element you want to connect to, and you would pick those from here, put their IP here. I know in this case I am connecting to MME, so I'm going to leave it selected to MME, and I know my MME IP address is 135 this. I know my login password here, so instead of a predefined key exchange, which is stored in eDAT and PC and the other network element, a predefined credential, so you don't have to provide your login password. I know I don't have that capability, so I'm going to use custom credentials, which is authorization mode, predefined or custom. So in this case, it's custom. So I will be entering, as soon as you chose custom, the password is highlighted. In predefined, you don't have to enter the password. But as soon as you custom, the password is highlighted. And I'm going to enter the password here and see if I can connect and see if there are any call trace log file using Secure Cell. This is the tab to use Secure Cell. You could use SFTP for file transfer also, Secure File Transfer Protocol. Again, you could do the same IP address here, the username and password for SFTP on that network element. And RSP is mostly for Verizon network. It's a reality services platform. I don't think I should be talking more on this. Most of the folks here, I don't know whether they are working on Verizon support, but I think my understanding is they are not. So I will not be talking on the RSP tab here much. If you have concerns or if you need that, please let me know by asking a question. So I'm going back to my SSH tab here. These are the three ways you can connect to the network elements, or two ways mostly, SSH and SFTP, and download the file from that network element. So after I put my login passwords and the IP address which I know I'm going to hit OK button, and it will connect to that network element. Hopefully we have the right connection, everything works, and you see now eDAT is connecting, and a new tab has opened up with that IP address, initializing. Please wait, and it has connected to the far element 135.251, 113.132, and which is an MME there. We know because we chose MME there. And it's showing me the file, directory file structure on MME there, and on the left side, and my own PC, and its own, my PC is on the right side. So this is my PC on the right side. This is the files on the MME. And if you scroll down, you will be able to see different files there on the MME there. And as I told you, an MME call trace log file is usually called protocol monitor.log. So somebody has done some call trace there. Remember, through this means we did not start a call trace. All we are doing is downloading the call trace log file, which is already existing there. Starting the call trace, stopping the call trace is another function I will show you subsequently in the slides. So I'm clicking this protocol monitor log file, and I'm selecting it by using a check mark, and I can download that file up on the top as you see, or I can go ahead and create a new project by clicking a new project of eDAT right away. So it will download as well as create the project all in one step. In this case, I'm just going to create a new project. So I'm using this protocol monitor log file, which is in a lab in China. I'm going to hit the create project button and add by create new project, and here we go. As soon as I click, it's downloaded the file, and I see the file being downloaded. It says it has downloaded this file. It must be a pretty small file because it went pretty fast. Once this file is in there, you can see the event, LT, and all that stuff, all the metrics tab on the bottom, which is what is highlighted, has filled up. So basically all the metrics are calculated by eDAT, and the project has been processed. I can now go ahead and close this connection. I don't need this manage file. So I'm going to close this by clicking on the X button. I can go back to doing what I was doing for call trace here, which is message flow, and you see that they have been filled up again. And I had closed this previous project, so now we have data in message flow, message explorer. So now I load that file up, the one we got from the China lab, and you can see the call trace message flow diagram for that file. So in this call trace log, somebody did already have a call up, and it starts out with a delete session request. So there is a delete session going from S gateway to MME, and a response going back other way. So you can see all the details we talked about. There is and there might be multiple UEs being traced here. We don't know what they did there when they started the log, what sort of call trace log they did. So you could see an update location request from possibly another UE or so forth. And this is only one thing to mention. This is only the protocol monitor log file, which is from MME's perspective. So you can see that the MME and eNode B on the far end, but this is, we haven't added the XML file from eNode B call trace for the same call trace which was done by somebody there. So this was only showing you the MME call trace log file. There is an attached request accept here. Bearer setup success is taken place here event. So the bearers have been allotted. An attached event occur, and so there might be multiple calls going back and forth. Any questions, please, on this one? So I showed you how to connect using eDAT and WTA to a far-end MME and downloading a file. By using, again, I will walk up here from file.
Can we stop for a minute, Mike, just to remind folks on the bridge, if you would like to ask questions, hit *7, and you can unmute yourself. And on the live meeting, you can also post questions with Q&A.
Thank you, Pete.
One question I have, and it's more of an illustration, I guess, is if we can click on, say the downlink transport message there, and scroll down to the details view to show, I think you mentioned this, but show that what you're seeing up top in the what we call the summary view is your message name. But down the bottom, you have not only the message name, but you have the information elements that are defined by the 3GPP standards, and all the information elements that are available in that message are decoded. And in this particular case, this happens to have a NAS PDU in it. So what we do with that NAS PDU is generate I think you scrolled down one, but anyways, a NAS.
This one.
Yeah, NAS downlink transport message. Inside that, there's the embedded NAS PDU, which we decode into the security mode command. So,
right.
If you were looking at the file, the log file, you wouldn't see the security mode command. You would see, the NAS PDU, and we're decoding it and its information elements and providing that detail down the bottom. So the summary view up top, details down the bottom.
Right. So if I was to click on downlink NAS transport, it shows me the NAS PDU as there's a different color here. I'm highlighting here on the screen. I hope folks can see that. And then if I were to click the speed set and the security mode command, you would see more details on that decoded message, right, Pete?
Exactly.
Yeah.
You had mentioned it before, but I just wanted to illustrate it. We're not just showing the traditional flows, we're also showing the decoding the details underneath.
Yeah. Thanks, Pete. Appreciate that. Thanks for noticing that. I didn't notice that on that message. Any questions, folks, on that? So we have downloaded a file and using connections, SSH connection to a far distance MME in China in real time, and we bought the file and we post-process using that all through eDAT in one central location function of eDAT and WTA using SSH. Anything?
The difference between the MME file structure and the SAM file SAMOC server structure connected to the SAMOC? Use SFTP. I have the IP. You don't have it there.
Yeah, we are going to connect to SAM. I don't have the SAM IP, but
I do, Mike.
Okay.
It's 135.25. That's it right there.
251.32.
Yep, third. Well, you got one too many dots.
Okay.
You got an extra dot in there. WTA is the username.
Yeah.
You know it.
So I'm connecting what Pete is suggesting that we'd use SSH before. We are going to use SFTP and connecting it to a SAM, a different network element, SAMO. And what happened here? Okay. And we are going to connect to SAM to download the files. What we did before was MME. We could do eNodeB files similarly. So I'm trying to see if I can connect. Okay. I typed something wrong.
You have two exclamation points at the end.
1, 2, 3, bang, right?
Two bad. Two ball bad.
2, 1, okay. Thanks. Okay, so we are in business with connecting with SAM now. Similar function. Wow, why did it say connect to another NE? I guess we got another NE for some reason. Having some difficulties connecting to the SAM location in China, but
They may have done an upgrade on their SAM.
yeah, because it says connect to a different element.
That's because there may not be any call trace files there now.
Yeah, it's just like there is no call trace log file when you do a software update or retrofit there. You wipe out the old data there, and they must have done that. So it's not able to find any call trace log files. So that's why eDAT comes back to you want to connect to a different network element because it has not found any call trace log file. Basically, eDAT when it connects, WTA when it connects, it looks for those type of files for call trace.
Yeah, there's a specific directory on the SAMOC server that has call trace, and
right.
If they're not there, we say, oh, there's nothing there, so you want to connect to something else.
Okay, any questions on that, folks? Connecting, we did network into MME and SAM for eNode B, and tried MME. We were able to download the file and post-process it. The SAM, you would have to do the same way. If you had an eNode B file there on the China lab, you would be able to download that similar way, process it similar way, and load it on call trace, message flow, message view, similar way. Same thing, similar way. So basically, if you could do SSH, SFTP, you could connect to MME, SAM, or XMS using any of this, ping their IP and the password, and then connecting that way. Any questions up till now, please? I have pretty much shown you connection to SAM and X using SSH and SFTP option. We use both. So both of these window screens are pretty much explained here. Again, these screenshots are also explaining online help also, as I showed before. So once we connected the file, you saw me post-process the file from MME. You could download the file or add to the project. We went through the route of adding to the project directly and creating the project instead of downloading. So it was all done in one fell swoop. This is the RSP case, which I'm not going to talk much because I don't think folks here deal with Verizon networking here. If they do, RSP is a reality services platform which collects all the data files from various Verizon elements, and we just connect to RSP and download it from there instead of connecting to the Verizon's network element directly. So that's what capability is provided even in eDAT also. So RSP is like a repository of all the call trace log files from different network elements for Verizon. And eDAT provides you to do that also. We talked about slide 36, Message Explorer, pretty much by going here from View. I'm going to close this window. From View, Message Explorer, we already talked about that by loading the project study, and this is what you are looking at right now, which is a message flow. And the same Message Explorer you can view by clicking on View Message Explorer. So we did talk about slide number 36 for looking at Message Explorer and message flow for call trace log files. And if you have any questions, folks, please feel free to speak up anytime. Slide number 37 is showing a message.
Mike, can you go back to that one? Just since we have internal folks here.
Okay.
And talking eDAT, you point out that you can do the put the call trace in there and UE drive test data together inside of eDAT, not in WTA. So you can process both drive test logs and call trace logs in eDAT.
Yes, we can do both in this. We can do in eDAT, I already mentioned that before, but I'll mention again that eDAT can do drive test data as well as network element log files. So we can put everything in one step here. So let me close this project which I was showing here, and I will try to see if I have an example of that short. So I'm going to close project one. Do you want to save? I say no, I don't want to save anything. I'm going to see if I can open another data to process, another call trace log files to process. So I can even do new. I can just click on this new project button. I am going to go to my desktop and presentation folder where I have all my stuff. Demo data files, and let's see if I have something. I have something here, some files which have a protocol monitor log files. I have eNode B log files. As you see, those XML files, these are all eNode B files. And I believe there is LLDM call trace log file, which is a drive test data file. So it is an Agilent tool which captures. If I hover over that file, you can see it has captured all those DML files, and I'm going to load that up all in eDAT, which eDAT allows you to do. WTA will not process this LLDM file, but it will process these other files. So I'm selecting all these files together. So I've selected all these files to load in that. This is the example, Pete, you wanted, right? I can show that,
Yes.
Pete?
Yes.
So once you select and highlighted them, I can just hit open here, and you see that eDAT has loaded all the DML files in there, and I'm just going to unzip that zip file of DML, and I'm just saying OK. So it is loading the protocol monitor log file, which is from MME, and then followed by this XML files, which are from eNodeB. As I discussed before, right in the beginning, it has processed those. And now it's moving on to processing the DML files, which are the UE drive test data file, as you see the progress there. And pretty soon it will be loaded, hopefully, and then you can see the UE files also along with eNodeB and MME log files all together in the call trace log file. And as I mentioned that before, you don't have to put, eDAT takes care of putting all that together and correlating the information of various log files based on when you collect it and all that stuff. It looks at timestamps. So if, let's say, an RRC connection request was to go from eNodeB to MME, if you are to capture a log trace file, of course, you will see the RRC connection request going out towards MME in the eNodeB log file, but the same message will be shown as incoming in the protocol monitor log file. But eDAT takes care of correlating all that stuff, so there is no duplicacy. It will remove all that stuff. It will just show a nice one single message coming from eNodeB into MME when it puts all that in perspective for you in message flow, message view. So it does all that coordination. The same thing for UE drive test data also. Any questions, folks? It's taking a little while to do the DML processing. While it's doing that, I am at the slide number 36, folks, and this is slide number 37. We pretty much talked about it while it processes. I'll go back to once it's processed. We talked about the Message Explorer view, call trace data log, which is on the top is the summary view. If you click on any message there, you see a detailed decoded message view. We talked about that as Pete did, and thank you, Pete, for that. If I was to go to Message Explorer bar, I talked about the bookmarks, clearing the bookmarks, how to set a bookmark, and you can toggle a bookmark using the icons there, and you can do different things provided by on this call separation messages and call failure messages. You can mark them using bookmarks and send it to somebody in a PDF file or a different files which eDAT provides as export, and you can share them with that and say, this is my failure case here, please help me investigate, or please let me know why is happening this. You can do that with this tool. We already talked about these bookmarks also, so I'm going to skip ahead with slide number 39. One of the things I forgot to mention was the time diff. If you were to select one message which you wanted this message occurred at this time, and then you select this time difference icon button, which is true and shown, and then you would select any other message which you would like, eDAT would come back with the time difference and show you what's the difference between the two timestamps of when they occurred. I'll go back. A question on the bridge, please? Okay. I'm going back to that eDAT where the files have been processed. You see with the UE data, there are a lot more metrics here and stuff. Now we have the drive test data, the eNodeB file, and the MME file, all the three of them together loaded in eDAT. I'm going to click the view, the famous view button again for message flow, project 1, study 1, and if as the message flow diagram loads, you will see that all big files have been processed, and you are getting a nice message flow view of all the thing which was captured in the protocol monitor, eNote B, as well as the UE file, all put together in perspective for you in the message flow view as it loads up. Bear with me till it loads up, because usually the UE files take a little while to process because these are LLDM files. So slide number 39, folks. Any questions till now while we still wait for processing that? On 40 slide also we had those bookmarks and events which we talked about. I showed you the slider bar capability also. So we did talk about slide number 40, slider bar, where you can do a sliding bar. Events can be viewed in a sliding match. You hover over any event, you can see what occurred. It's like a nice TV type view when events occurred over timeline. And a slider bar, if you were to click on some event, you would go right into that event also. I showed you that. So here we are with post-processing that huge file we had, which was a real big file I had. And we have processed it in eDAT. We are back into eDAT, and you can see the UE having UE number this and file this, and you can see the UE message is also being processed in here. And you can see eNote B messages going, UE message going to eNote B and other network elements. So this is a MMEs and all that stuff. Again, as Pete mentioned, we can do filter by message group, by mobile. If you want only filters for certain mobiles, and you would to click on this one, you would say OK, and you would get only those messages. So you can see that I did the filter there, and you are seeing the only that UE messages here, and going back and forth here in that screen display. You see that the eNote Bs.
Yeah, that actually brings up a good point, Mike. Scroll to the left there.
Okay.
I mean, since this is drive test data, one thing that's different, and you guys know this because you use eDAT, but you get the layer 1, layer 2 information, the messaging going between the UE and the eNote B.
Right.
So with drive test, you have layer 1, layer 2, and layer 3. So your RSE messages, which are the layer 3. Now, when you're talking about call trace data from an eNote B, it's layer 3. So it's your RRC messages on the UE, the eNote B, the UU interface. But on the eNote B to MME side, it's the S1 messages, and also the X2 messages. So that's the difference. I mean, if you put both together, you have layer 1, layer 2, and layer 3, but you also extend from the UE out to the MME. With drive test, you don't have that visibility out to the MME. Right. So that's the, when you put them both together, you have a very complete picture.
Yeah, thanks, Pete, for that, pointing that out. And if folks who are familiar with layer 1, layer 2 messages, you see this master information block, system information block, PDS. These are all layer 1, layer 2 messages, right, Pete? So these are all, you can see them now in that.
Correct.
Right. And if you were to click on this, you would see more details of this master information block on the bottom here. So you can get more details. As you see that I clicked on master information block, and you can see the various details and hex codes and all the bits and bytes which you would like to see, and they are all decoded nicely for you here. What is the system frame number and the PH and all that stuff, bandwidth number and all that stuff. Any questions now, folks? So this is containing the UE data also, and it's containing all the files, the UE data, the eNote B file, and the MME file. All of them have been processed together. Any questions on the bridge, please? And thank you. Okay, if I was to go and load the Message Explorer view for this event, for this same project, I can do the same Message Explorer view of this same file, and I'm loading that up now, similar to what I had the message flow.
I have a question about the LLDM or UE messages. Is the tool able also to post-process it in less than 10 millisecond time frame?
When you say 10 millisecond time frame, I'm not able to understand from where are we talking from 10 millisecond time frame. Are you telling me?
Yeah, I have just post-processed many LLDM logs so from LG UE, and the minimum binning in that case from the signaling messages was 10 milliseconds. But in LLDM there are two possibilities. There is a timestamp in 10 milliseconds, and there is a so-called cell time, which is on a 1 millisecond binning, so really on the single TTI. And this makes also the calculation of latencies on the signaling messages more precise. So, but I was interested to know whether the tool now supports also binning, let's say, at 1 millisecond also for signaling messages.
Go ahead, Pete.
I'll take that, Mike. Yeah, the binning can get down to 1 millisecond, not limited to 10 milliseconds. If the data is available in that granularity, yes, we can bin down to 1 millisecond. And that's something that's been added in the last year. So I know what you're saying, that some of the messages come in, and depending on how the messages are collected by LLDM, sometimes they do it in 100 millisecond blocks, other times they do it in 10 millisecond blocks, and then inside that they have the 1 millisecond data. So if it's available, we allow that binning to that level.
Okay.
Yeah, and if you have a specific request or a question about that, then I would suggest you send an email to us, and we can get the appropriate people involved.
I have raised already this point actually to the eDAT team already a couple of months ago. So
okay.
I would like just to know whether this was implemented. I have not time so far to check the latest version 6, but I will double check again. Set the temporal insight to 1 millisecond and check if also this is reflected in the signaling messages.
Yeah, and who was asking the question? I can follow up too. Who was asking the question?
My name is Matteo Trevisi from.
Matteo. Okay, Matteo.
Yeah.
Thanks, Matteo. Appreciate that question. Pete, is this the same setting we are talking about, what I'm showing you on the project there? I think the options.
It depends on the data, Mike. It's a little bit more complicated than that, but yeah,
okay.
that's kind of the setting. It depends on what the data is in, and I know there's been some discussion that has been going around on the system engineering team. I just don't know the latest, so we have to follow up with that, Matteo.
Yeah, we'll get back to you, Matteo, on that. So thank you for asking that question.
And there is another question coming in from the live meeting here. Just pull it up. Okay, can you show us how to analyze MME and or SGW relocation? I don't know that we have data for that particular scenario.
No, I don't have that one, but if you have the data file, we are more than happy to process it and show it to you. I don't have any SGW files at all.
No, but we would see it doesn't have to necessarily be SGW file. You could have a MME call trace that would have a relocation of the SGW, or even the MME. So we're transferring call to a different MME, like a handover between MMEs. I don't have any data that shows that. I mean, it'd be similar to tau, but it's more for the MME.
Yeah.
So I don't have any data that shows that. If you can supply us with that scenario, we'd certainly be able to show that scenario inside and show the messaging and how you would take that and break that apart. I'll see if I've got some data. The data that we have from labs is very limited, obviously, but the data we have from fields, we have a lot of data from the field, but I don't recall that scenario off the top of my head, but I can look at it some more.
That's SGW relocate?
No, it's MMEN or SGW.
Okay. Well, if you have it, you can email me, and I can get back to you after post-processing.
Yeah, I've got a note for TC to I will follow up with that too, Mike.
Okay, thanks.
I've got some notes here, so.
Okay, thanks, folks. Any other questions? These questions are good for us. It helps us to make our tool better too. So remember that it's a two-way street. We also learn from you in that way. So please do feel free to ask questions. Moving on to the slide 41, if there are no questions, I think we pretty much demonstrated the filter group, the message filter. I did the demo when Pete asked me. So we did cover the filter part of demonstration already. So I'm going to skip this slides 41 and 42 and 3 and 4, which assigns to define you the message group. Similar work, but you can define a filter based on a message group. Once you have a call trace file loaded, you can define a filter which you want to filter only on certain messages, rename it, name the filter RRC connects and request filters in this case, and you will only see those messages in that filter. But okay, if I can skip and go ahead, Pete, that way, and that we already did that demo.
Yeah, I'm okay. I mean, they've got this as a takeaway too, so
yeah,
it shows them the stuff.
This next demo is color coding a message. If once you have the Flow and Explorer loaded up, you have ability to code it up so you can keep it for future or share it with make it stand out and stuff. So if you are to connect, click on any message here, let's say for example, and then you could possibly color code it there. Select color, second mouse button, and you can get just select color, and you will get a pop-up window which selects the color. You are able to select the color and modify the color of that message depending to what you want from the color selections. Anywhere you can select it from the automatic or standard colors or known colors. So it allows the ability to select colors, reset the color which you have selected on that. In this case, I just select some colors, and you can see that all the paging message have become a different color now since I made them. So I'm going back to select color again, and I'm going to say reset color, and it will be reset back to the color I want. In this case, we had so many paging messages, but I can just select one color on the PDN request connectivity request message, and I can color it up to, let's say, red or something, and you can see that only those messages will be colored differently now, so they can stand out and you can view them much easier. I resetted the color back. So any questions on the Message Explorer capability to filter or color code a message and search messages? Any questions on that, please? This allows you better ways of doing your debugging in the field. So as you show those in, go ahead.
I would suggest we just skip over, this, and as we are past the time allotment, but I think it would be good just to show if folks are interested in seeing how we could, the steps to do the call trace activation, just look at those slides for a few minutes here.
Sure, Pete. Sorry, I lost track of time there.
No,
but
okay.
We pretty much covered up the slide. I have talked about mostly all the slide. I'm just going to scroll quickly, and I'm going to jump to section 6, which is starting the call trace. And for that, I am going to close this project. You can keep this open and you can still start a project. So it allows multiple things to do at the same time. But I am going to close this project and show you the views screens for starting the call trace. So in this, up till now, we have seen ways to process an existing call trace log file on the PC. We have seen ways to download a call trace log file from a network element MME as XMS or SAM and download that log file and bring it into the PC to process and do call trace. The third function, which is an important function, is how to start the call trace on that network element. And eDAT allows you to provide that facility to WTA also. Again, as I told you, I'll remind you, it requires a separate OI code, but you will see this call trace pull down menu once you have that separate OI code and the license for that eDAT plus this OI code, which is a different OI code to have this capability. And this limits the folks who can start the capability, can do the call trace start, because not most people want to not most should start the call trace because it is performance impacting, but most people can do post-processing. So this is a separate OI code. Here we go with the call trace. You click on it, you can get an initiate call trace. You click on it and we will get a pop-up which will show you how to start a call trace on MME, XMS, which is for eNode B, or a SAM for eNode B. As I said in the beginning, you cannot start a call trace on S gateway or P gateway in this release, but somewhere in this is a 6.0, which is a March release, which I'm demoing. But in future releases, we will pretty soon we will add the capability to start a all trace, hopefully for S gateway and P gateway also, and you would see those tabs here also then. But once you come to this, you can start MME. You would add the host name. You would put the IP address of the MME where you want to start the call trace, IP address of it. You would use the username which has been assigned for that MME, which IMSIs if you want to start the call trace on any target IMSI. Remember, this is an MME call trace. MME has the knowledge of IMSI. So you could put the IMSI call trace here, and you put IMSI numbers here, and you could start the call trace that way. So you have ability to put the IMSI, and
you have to put the IMSI.
You have to put IMSI. Yes. Thank you, Pete. So that, and if you want to do the call trace on that MME and also on the eNode B, which is what I was talking about, which is called as a signaling call trace, you would click on eNode B, and as a parenthesis says, now, of course, it's a signaling based call trace on the eNode B. So this call trace started on MME will be propagated to eNode B, and you would have call trace on MME as well as eNode B for that IMSI which you have specified. And you could choose your interfaces, either all, S1 MME, or any particular interface which you are interested. Only certain, that one you can choose and select them from that menu. And of course, for collecting the call trace, when you select eNode B, who is the collecting entity? It could be either XMS as an ONM entity or SAM as an entity. So based on that, you would just select SAM or XMS, and you would put their IP address of the XMS and the username of the XMS. If it is SAM OX, then you would put the IP address, username, and password for that. So the call trace log file would come back from eNode B into that SAM server, and eDAT would initiate the call trace, pull that down, and as in the link here, as it says, save to. So if it will save these files when they are generated, it will save in this directory, default directory. You could change that by clicking this button and choosing a different directory if you want. If those call trace file, they will be pulled automatically from those network element. If you have set this automatically download call trace log file, automatically process after download. So you could automatically process also the call trace log file as it comes. So if you are to start it on MME, for say example, the call trace is being generated, it's getting bigger and bigger, the log file, eDAT will keep on continuously polling the MME based on the option setting. There is a certain how frequently you want to poll in these tool options. there is a setting how frequently you want to change. You can change that setting. It's a user settable, but there is a default setting. So eDAT will keep on polling those call trace log file from MME, SAM, or XMS and create the new call trace, keep on appending to the bottom of the call trace log file message flow, message explorer as it gets those log files. So it's like Unix tail function. So it will keep on getting and growing those message flow and message explorer views. If you have clicked those automatically download and automatically process download. Once you fill out all this button will be highlighted. I don't want to start the call trace in any lab. Somebody might be doing something, but once you click this start call trace, it will be started on that. A similar tab for XMS also, and again, as you see on XMS, the difference is here it's of course here it was a signaling based trace if you click here, but from now if you were to go to XMS and start a call trace here, it would be a management based call trace, and also the SAM would be a management based call trace. And both XMS and SAM tab allow you to do event-based call trace by setting your thresholds. If you want to set a threshold, if it exceeds something like a certain number, please start. If RRC re-establishing threshold exceeds somewhere, start this threshold. If IROT handoff threshold exceeds this number, please start call trace. You can even do event-based call trace on SAM or XMS. Again, the similar flavor of host name, IP address, username, password, and all those login details are there. In this case, you can provide LTE cell list also in SAM and XMS you want to so. I think this is also needed, so you do have to provide what those things are needed when you start the call trace. It's a management-based process, so you would have to fill out the LTE cell list on XMS and SAM. Once you start this call trace, as our slide shows here, this is where I have covered how to do init, emit, MME, XMS, or SAM. I covered this slide. I have covered the description of this. Again, all this stuff is in the online help menu. The screenshots are explained in real-time help, which you can go from here to index, and all the screenshots are there already explained also what to fill in there if you have any questions. Once you start all this, any call trace, you will have, since I cannot start the call trace, you will see right now you see in this eDAT only projects and info tab here, those two things pulled down, but you will have a call trace status pop up there. So you will have a CT status attached here, which will pop up once you start a call trace, telling you that you have done a call trace through eDAT or WTA. If you were to click on that thing, you would say, if you will see what trace ID you started, your MME, and it would details of everything you started on the call trace, on what active call trace that are going on, host name, IMSI ID, and it's initiated. You can stop the call trace also from that. Once you click on this CT status, you can stop it, or you can get the status log. If is it active, it is what is it doing there. You can get a status log also, or you can stop it. If you have multiple call traces, you will see multiple lines like this, and you could also stop all call traces using this button, or you can start another call trace using this initiate button. So this slide provides you the details of what will happen. I cannot start a call trace in any lab, don't have that liberty to do that and disturb somebody else. So, but this slide pretty much explains how you can even use eDAT to start the call trace. So eDAT and WTA are your like a one-stop shop for all your call trace analysis, post-processing the file, downloading the file from the network element, or starting or stopping call trace. Everything can be done analyzing wise, and everything right from starting to the analyzing, everything can be done through eDAT and WTA call trace function. I am on slide number 57. That was pretty much the last slide. I have overextended my time. Sorry about that. About 14 minutes speed. Any thoughts you want to add, or any folks have any questions? I would appreciate it. Thank you for your attention in that case. Please feel free to ask any questions you have or suggestions.
Yeah, Mike. Go ahead.
I have a short question.
Sure.
For the call trace enablement in MME, so there you can only put a username, but where can you put the password?
MME for call trace is different, set up differently. You need to have a satellite agent installed on the MME. So there's something that facilitates that key exchange with the MME. In LE 3.0, it's not part of the product. In 4.0 and beyond, it will be part of the product. So it's a satellite agent that needs to go onto the MME. So when eDAT or WTA talk to the MME, they do a key exchange. So there's no password required, and that LSS is the login that's used, and there's a key exchange for the password that's done. So the MME is a little different than the SAM.
As I see in the screen, there is no password on MME. Thanks, Pete, for that. And there is a similar stuff for hostname, username on eNodeB also, right, Pete? So XMS also, I mean.
Correct. For XMS and SAM, you definitely
right.
see.
And the SAM has a password in there. So you do have password on SAMOX and SAM, but XMS and MME do not have password. So it's basically going through the authentication keys there, which is preset by the satellite agents. So the satellite agent, that's why once you get the initiate call trace capability for the OI code, you do need to make sure that you only provide the OI code for folks who need to start the initiate call trace. That's why the initiate call trace button, which I was talking up, requires a separate OI code. This one, even though you may have eDAT OI code and you can do all other analysis and everything, the initiate call trace is only available if you have that specific OI code. They say it right, Pete? Right?
That's correct. And the reason we did that was we were working with Verizon, who lets us do things in their lab, and because now that we have a satellite agent there, we're able to collect their data off their network and store it on the RSP platform. So for back-end folks, so if you are supporting Verizon, we have all their call trace data across their network because there's an agreement that we have with them. They allow us to do that. So, you know, if something happened 2 days ago, the trace data is there if they were running it.
Yeah, I was talking about that reality service platform, which I did not talk much, but I skipped on it a little bit. Right. But this is the RSP platform. If you see this tab, RSP, reality service, if you are to connect to a network element, RSP is a separate server, which the agreement with Verizon and Alcatel-Lucent, RSP has the ability to download all the call trace files routinely from the network elements. And so the users don't have to log into the network element directly into Verizon network if somebody from Alcatel-Lucent is going to look at that. So they would just go instead log into the RSP using this tab, username, password. If they had the valid RSP, they would be able to see all the call trace log files from this RSP server, which has done the work of downloading it from the Verizon routine basis, and then you would just post-process from there.
Right, and obviously, one thing to add further to that is AT&T doesn't have our MME right now, so it's not applicable to AT&T yet. You know, that hopefully will change in the future. But right now, AT&T doesn't have our MME. Others, you know, I don't know what other customers are planning at this point, but those are the two that are in our sites right now. And I imagine others like Orange or somebody like that will be different. So those would be things we need to work out as we move forward.
Thank you for that question. Any other questions on the bridge, please? Any suggestions, inputs? Feel free to email me. You have my name, number, and emails all on the first slides. But feel free to ask any questions now if you have any, please.
While folks are thinking a bit, I know, you know, you folks in Europe joined late because of I suspect it's because of the time change or something, but what I would recommend is this session is being recorded, and I will have the recorded link from the ALU people, university folks, later. So I will send that out. Basically, the first hour was covering a lot of the fundamentals of call trace and like the trace session reference, the trace recording reference, those things. So I would recommend you take a look at that if you're interested in seeing what you may have missed. do that. And if you have further questions, let us know. And if we need to do a separate, shorter session to go over some of that, we're open to that as well. But I think the recording will bridge that gap for you. But if it doesn't, let us know. Noel had let us know that you were late. I didn't realize it until she had mentioned it. So just want to let everybody know that it is being recorded and will be available. The other thing I wanted to bring up is there's often, when we talk about the call trace functionality, often questions about particular scenarios. One of the things I'd like to reach out to everybody here is if you have particular scenarios and have access to the data to provide us with those scenarios, your troubleshooting, so we can, obviously call trace from the LTE perspective is relatively new. So there aren't all these scenarios, cataloged in a database that we have to date. So as we learn from the field or work with customers or work with you folks that are working with customers, we learn more. So if we can capture data that can illustrate a particular scenario, we can incorporate them into future training, not just our training, but customer training, which we're developing as well. Because it's difficult to come up with those troubleshooting scenarios without having, actual field data and things like that. So, just reaching out to you all to say, hey, if you've got something you want us to look at, by all means, we'd be more than willing to work with it.
Yeah, thank you, Pete, for pointing it out. And I agree with Pete. We are developing this course, and one of the things we want to do is to add more scenarios where failure cases are, for example, as Pete said. So if, let's say, an attach failed or something failed, we would like to show to the folks with that scenario, this is how you would load this up, and here is the attach failed. This is how you would say an iRAT failed, or this is how you would say an S1 handover failed. And if we had those scenarios as we get them, and we can build a knowledge base through that for folks, and people can better use this tool much better that way. Thanks, Pete, for pointing that out.
All right. At this point, I'm going to do one last call for questions. Any questions on the bridge? If you do, *7 to speak up, or on the live meeting, you can post them on Q&A. I know we've gone over by 20 minutes or so, but I think I was given a little latitude since folks had joined late. So one last, any questions? Okay. If there aren't any questions, what we'll do is we will wrap things up here, and I want to thank Mike for going through the training, and thank all of you for attending and providing us feedback and questions. And we look forward to hearing more from all of you and working with you with the call trace functionality. I know some of you have already worked with us on other things, so we look forward to hearing more back from you. All right.
Thank you, Pete, for the great help. I appreciate this. Bye.
Okay. Thank you, everybody.
Thank you, Pete. Bye. Thanks, everyone. Bye.